Okay, we want the Maclaurin series here, so we're going to have to first think of this as a partial fraction problem, where it's a over 1 minus x plus, now this is a repeated repeated uh, term here, so we can deal with that by saying it's b over 1 minus 2x plus, and then here we have 1 minus 2x squared, and we can either put here c or cx actually. Does either make a difference here? Do I want to go? Oh, yeah, I want to go with C, of course. That'd be easier. Yeah. Okay. So that means that 4x squared minus 3 is equivalent to, if I multiply everything by this denominator here, so multiplying all these four terms here by these two with the square, so you'd be left with just 4x squared minus 3 obviously on the left, and that would be a times 1 minus 2x squared plus b times 1 minus x 1 minus 2x plus c times 1 minus x. Now this is an identity which is true for all values of x, so if you let x equal to 1, then that would mean you would get minus 3. No, you would not get minus 3. You would get 4 minus 3, which is 1, should equal, gone. 1 minus 2 is minus 1 squared is 1, so that's a. Okay, next we should let x equal a half. So that would mean we'd have a half squared is a quarter, times 4 is 1, 1 minus 3 is minus 2, equals 2 times the half is minus 1. So I chose that to make these two disappear. And 1 minus a half is a half. So that's a half c. So that means c is equal to minus 4. Then what we can do is we can just let x is 0. So then that means you have minus 3 equals a, which we said is 1, times 1 squared, plus b, which we don't know, times 1 times 1, plus c, which we said is minus 4 times 1. So then that would mean then that minus 3 equals minus 3 plus b. That's interesting. So that means the b is 0. So our 4x squared minus 3 over 1 minus x times 1 minus 2x squared is equal to a, which is 1 over 1 minus x, plus c, which is minus 4 over 1 minus 2x, all squared, which is equal to, the Maclaurin series for that is well known. You can get it by long division as well. It's 1 plus x squared plus x cubed, etc. This would be minus 4, and it'll be the same as 2x minus 1 squared. So really our job is just to get the series for this one. Any sneaky way of doing it? No, I don't think so. Unless if I was to change it into an integration. So let me just go back a step here. So that's 1 over 1 minus x minus, let's just think about this. that's a minus 2. So I could say, if I thought about it as a derivative, let me just think about this. 4 over 1 minus 2x. So that's minus 1. So you bring the power down. So that means my sign is wrong there. Reduce the power by 1. You'd get the square. And then you'd have to multiply by the inside derivative, which is minus 2. So I think if I change the top here to minus 2 times that, and then if I multiply through by minus, I can change that to plus and then 2x minus 1. Okay. Oh, do you know what? Actually, I want to do it the other way, sorry. Yeah, it's better this way for me. So let's think about this. That's 1 minus 2x power minus 1. Bring the power down. That's minus 1. Reduce the power by 1. That's minus 2. And multiply by the inside derivative. So that's minus 2 times the 1 is positive 2. And if I already have a negative 2 outside, that becomes negative 4 over 1 minus 2x squared. Yeah, so that actually matches up. Now the reason I'm doing this is so I don't have to go through the trouble of doing the Taylor series, the Maclaurin series. So this will equal 1 over 1 minus x. And we actually, as I said a moment ago, we know that Taylor series. It's 1 plus x squared, etc. Minus twice the derivative. And we know this Taylor series is the same as the first, Maclaurin series is the same as the first one, but instead of x, it's 2x. So that's 1 plus 2x plus 4x squared, etc. So that will equal 1 plus x squared, etc. minus 2 times the derivative of that. That's gone. That's 2 times minus 2 is minus 4. Maybe I'll leave the minus outside, so it's 4. That becomes 8x times 2 is 16x. The next one would have been 8x cubed, so it would have been 24x squared, so that would have been 48x squared, etc. Okay, so that's 1 minus 4 is minus 3. Then it's x minus 16x is minus 15x. Then it's x squared minus 48x, so that's minus 47x squared, etc. Yeah, that looks like it's it. I wonder what the next one is actually. The next one, out of curiosity, what would it have been? So that would mean 8, 2 cubed, 2, 4, 8, 16. The next one here would have been 16x4. Oh wait, did I get knocked out of sync? No, that's it. And that would have been 64x cubed. That's 100, it would have been 128. That's 127. So the next one would have been minus 127x cubed. Okay. So can we actually figure out the general formula here? So what's happening here? It would have been 2x power n. So you would have gotten your 2 power n. And then the power would have come down. and then you would have multiplied it by 2 again, so that would have made it plus 1. So it's looking like it's 2 to the power times a number smaller than the power. Oh, and then you would have taken away 1 from it. Yeah, actually, so if you look at these, let's just try and figure out the pattern here. It would have been 4 minus 1, 16 minus 1, 48 minus 1, 128 minus 1. And 4 would have been 2 squared, 2 cubed. No. 2 squared, 2, 4, 8, 2, 4. 2, you can't get to 48, can you? Yes, 2 times 2 cubed, sorry. 2 times 2 cubed. This would have been 3 times 2 power 4. 2, 4, 8, 16, 48 minus 1. The next one then is 4 times 2 power 5 minus 1. 2, 4, 8, 16, 32. Yeah, that's it. That's it. And this is first one, second one, third one, fourth one. So if I was to try and get the formula here, it would equal minus the sum from 0 to infinity n times 2 power n plus 1 minus 1 times 0. Oh, yeah, we start at 1. Oh, yeah, actually, it doesn't matter because, no, it does actually start at 1. Okay. But the powers are 1 less. That's x power n minus 1 then. So the first one is 1 times 2 squared minus 1. Yep. Well, maybe it would have been quicker just to, well, anyways, that's it done.